Hello students, secondary to chemistry. This is unit 4, representative elements of some regular groups. Now the lesson is elements of S group. Then we are going to study group 1A, alkali metals. We know that from the periodic table is classified into 4 blocks: S block, P block, D block, and F block. Okay, and now for the D block, this is called 1A group, 2A group, 3A group, 4A group, and so on. These are the B groups, 3B and 4B, and so on. This is F block. Now we are going to study group 1A. Group 1A contains the elements lithium, sodium, potassium, rubidium, cesium, and francium. These are the elements of group 1A, which is called alkali metals. Here all the periodic table consists of groups: alkali metals, alkaline earth metals, transition metals, and so on, halogens, and other groups. What is the representative element? A representative element is a group of elements which show regularity in properties. Elements which show regularity in properties are called representative elements. The alkali metals, group 1A, is called alkali metals. Elements of group 1A that the Muslim scientists give the name alkali to both of sodium and potassium compounds. These are the elements, the most important elements: lithium, sodium, potassium, rubidium, cesium, francium. These are the letters and their corresponding atomic numbers. These are the electronic configurations. Okay. These are the properties of some elements of them. Lithium, this is this smallest element here in this group. Sodium ranked the 6th in the abundance of the earth crust. It is very important substance. It is present in table salt and called rock salt. Potassium ranked 7th in the abundance in the earth. It is present in seawater as potassium chloride, and compound called carnallite, which is a mixture of potassium chloride and magnesium chloride, hydrated. Hydrated means contains some water in the crystalline. Rubidium element, cesium, which is a very sensitive element to light, so it is used in making solar cells. Francium, which is a radioactive element, and its half-life is very small. It's 20 minutes, its half-life. What are the properties of all metals as general? These are the properties of the metals: malleable, good conductors of electricity. All metals are solids except mercury. They have high or great atomic radii and low ionization energy, and the metals also have low electron affinity and low electronegativity. These are the properties of the metals as general. For group 1A, we are going now to talk some about the general properties of group 1A alkali metals. Each element here in this group 1A contains one electron only in the outermost energy level, so its valency is +1. These elements tend to form ions, positive ions, and the charge of each ion is +1 because each element tends to lose one electron only from the outermost energy level. They have low ionization energy, and also they have low electronegativity and low electron affinity and large ionic radii. They are called electropositive elements because they tend to form positive ions. If any element of group 1A or any compound, most of them have characteristic spectrum or characteristic light in the flame. Lithium chloride, for example, when put in the benzene flame, the flame becomes red, crimson red, like this one. This is for sodium, this is for potassium, and so on. Each element has its characteristic color, so you can identify the element from its color in the flame, benzene flame. How to get these colors? By obtaining platinum wire and embed this platinum wire in HCl to clean this wire, then taking some unknown salt of any element of group 1A by this platinum wire after cleaning by HCl, then putting this salt which is carried on the platinum wire in the flame. The color, you will get the color of the element, which is very characteristic for this element. The colors of these flames can be obtained on a sensitive film to have characteristic light, which is called the spectrum of the element. You can store the elements of group 1A in a container containing inert liquid such as kerosene, because these elements of group 1A are very active, so they react with the oxygen, atmospheric oxygen and atmospheric water and atmospheric carbon dioxide. And to prevent this reaction and store these elements, you must put them in an inert liquid such as paraffin oil or kerosene, as here in this figure. If you expose sodium to oxygen only, you get sodium oxide Na2O, because the oxygen is divalent and sodium is monovalent. By putting lithium in nitrogen atmosphere, you get lithium nitride. Lithium nitride reacts with water to form lithium hydroxide and ammonia gas, as here in this equation. Lithium and nitrogen, lithium nitride reacts with water to form lithium hydroxide and ammonia gas. These elements are active. The elements of group 1A are really active, so when they react with water, they react violently. Here is sodium react with water, potassium reacts with water. This reaction is very dangerous. The reaction is violent, so you must use very small amounts of sodium and potassium. This is the reaction of sodium with water to form sodium hydroxide and hydrogen gas. This hydrogen gas burn by the action with atmospheric oxygen and giving out heat, and the heat is seen as fire. In the same way, potassium with water, potassium hydroxide and hydrogen gas. Lithium reacts with oxygen at 180 Celsius degrees to form lithium hydroxide, lithium oxide compound. Sodium reacts with oxygen at 300 Celsius to form sodium peroxide Na2O2 at 300 Celsius. Sodium peroxide reacts with acid and with water to form hydrogen peroxide. And here sodium chloride, and here is sodium hydroxide with water. Potassium reacts with oxygen at 300 degrees to form potassium superoxide. Superoxide, not peroxide as in the case of sodium, but superoxide. At this oxide, oxygen has minus half oxidation number. Potassium superoxide reacts with acids to form salts, hydrogen peroxide and oxygen gas. Also, potassium superoxide reacts with water to form potassium hydroxide, hydrogen peroxide and oxygen. Potassium superoxide reacts with carbon dioxide in the presence of a catalyst, copper chloride catalyst, to form potassium carbonate and oxygen gas. This reaction is very important because potassium superoxide reacts with carbon dioxide and convert it into oxygen. So this reaction is used in spacecrafts to convert carbon dioxide produced from breathing of the scientists, astronauts, into oxygen, and the oxygen is used for breathing. So this reaction means that carbon dioxide is converted into oxygen, which is a very required reaction in the spacecrafts. Sodium reacts with acids to form sodium chloride and water, because as you know, sodium is a very active metal, which is more active than hydrogen, so sodium replaces hydrogen. Lithium reacts with hydrogen to form lithium hydride. Sodium reacts with hydrogen to form sodium hydride. Lithium hydride reacts with water to form lithium hydroxide and hydrogen gas. Metals of group 1A react with halogens to form halo salts. Sodium with chlorine reacts to form sodium chloride, potassium with bromine, potassium bromide, and so on. Also, these metals react with other nonmetals such as phosphorus to form, for example, sodium with sulfur gives sodium sulfide, potassium with phosphorus to form potassium phosphide, okay.